Hi everyone, and welcome to the Regulatory Compliance Best Practices video in which you'll learn how to use the FireMon Solutions portfolio, also known as the FSP, to help your organization meet its compliance goals. In this video, we'll be deep diving into tips and techniques that will help you prepare your FireMon ecosystem to effectively monitor and report on your compliance requirements. A quick note before we begin, it's assumed you already understand how FireMon controls and assessments are configured. If you're unfamiliar with those concepts, please take a moment to view the Compliance and Controls video, also available on this site, before moving forward. You might be asking yourself, what do I need to comply with? Well, compliance requirements will vary widely from one organization to another, but there are generally two types of standards you might be subject to. Security best practices mandate that internal or organizational compliance policies be created, documented, and adhered to. These internal policies will outline acceptable device configuration and permissible connectivity standards, which will then be enforced by the rules on your security devices. A good security policy should also specify the procedural steps to be followed in order to authorize and document any exceptions to those standards. Industry and regulatory compliance requirements will also specify configuration and procedural policies to be followed. However, unlike your internal compliance policies, these will be dictated by the agencies responsible for the relevant standards and will typically be subject to periodic audits to verify and document adherence. The FireMon Solutions portfolio can help you with both, but our focus in this video will be on how to use our product to achieve and maintain compliance with those regulatory standards. The FireMon Solutions portfolio comes with pre-configured assessments to audit your security devices against several regulatory standards, including the DISA-STIG Firewall Security Implementation Guide for Cisco devices, the General Data Protection Regulation, or GDPR, the Health Insurance Portability and Accountability Act, which you may know as HIPAA, the International Organization Standard and International Electrotechnical Commission 2007-001 Information Technology Security Techniques, that's a mouthful, commonly known as ISO 27001, the North American Reliability Corporation Critical Infrastructure Protection, aka NERC-CIP, version 6, the National Institute of Standards and Technology Recommendation Special Publication, or NIST SP 841, the Payment Card Industry Data Security Standard, version 3.2.1, commonly known as PCI DSS, Title IV of the Sarbanes-Oxley Act of 2002, used to assess the effectiveness of internal controls and procedures for financial reporting. The FSP can also provide assessments to audit compliance to regulatory device configuration benchmarks, such as the SANS Security Configuration Benchmark for Palo Alto firewalls. You can also create assessments for other benchmarks and vendors using custom controls built with our proprietary security intelligence query language. Many of our pre-configured assessments use allowed services and service risk analysis type controls. These kinds of controls will test what services and ports are permitted from one compliance zone to another. For these assessments to provide accurate compliance reporting, you'll first need to configure the relevant compliance zones and service groups. Compliance zones are defined by assigning the network segments contained within. To populate any of the pre-configured zones, simply open the one in question, the DMZ for example, then open the assignment section and double-click the relevant network segments, adding them to the zone. Note the warning, you can only assign a segment to one compliance zone. Segments will automatically be populated based on the network interface configuration of your devices. However, you can also add them in manually. Just click the Create button in the Network Segments page, give your segment a name, description, and optionally assign it a compliance zone and color. Service groups are exactly what they sound like. You can group together various services, ports, or protocols to use when building your controls. This allows you to create service groups specific to a particular application. If you have a custom service or port range, you can create a new control for it simply by clicking Create in the Services menu, then specify the type, give it a name and enter any vulnerability information you might have for this service, specify the level of associated risk from low to critical, and finally enter the port number or port range. Assessments also contain controls that will verify device or rule properties by examining devices, policies, and rules through filters or through inspection of specific configuration files using regular expressions, which many of you may know as regex patterns. Here's an example of an allowed services type control. This one tests whether ICMP Type 3 Code 4 services are allowed from any zone to any zone. This would specifically refer to destination unreachable messages caused by packet fragmentation. Here's a service risk analysis type control, which tests whether SNMP services are allowed from the external to the internal compliance zone. This device property control will test whether the zone protection profile is enabled on a Palo Alto firewall. These profiles will offer protection against flood or protocol attacks to block non-IP protocols at layer 2. As you can see here, this control will fail if the test does not return a result. Here's an example of a useful regex type control. This one looks inside the running config file of your Cisco iOS type devices to verify that none of them have their SNMP community string set to the default value of public. You can see the regular expression used, which will find the line preceding the community string in the raw configuration file, and if it matches the string public, in this case the query does return a result, this control fails. Here in the reporting properties, you can also specify the text that will appear in a report depending on whether the result is a pass or a fail. You can even provide some instructions on how to remediate the issue causing the failed compliance control. Let's now take a closer look at each of the pre-configured compliance assessments that come with your FireMon Solutions portfolio. We'll go over which requirements those assessments will audit, which compliance zones and service groups are used by each, along with other controls they might be testing your devices against. The first assessment you see in the list is FireMon's best practices. While this is not a regulatory assessment, it's worth noting that all of the devices that you manage with the FireMon Solutions portfolio will be assigned to the All Devices group, which by default will be assigned the Best Practices assessment and tested against the 97 controls contained within. Next we have the DISA STIG assessment, which contains controls that primarily check various configurations and properties on your firewalls. But there are also checks for Teredo packets, which allow for tunneling of IPv6 packets over IPv4, creating the potential to bypass packet inspection on your firewalls. The internal and external compliance zones, which will be the bidirectional source and destination zones checked for the presence of those Teredo packets, will need to be populated with the relevant network segments. There are 36 controls to verify various device properties and configurations, as well as 2 controls that check to ensure inbound and outbound Teredo packets are blocked. Using those controls, the DISA STIG assessment will test the requirements listed on your screen now. The GDPR assessment does not make use of compliance zones or service group, hence there's no need to configure them in this case. This assessment uses rule search and device property controls to verify that all connectivity is encrypted, that there are no unused or expired rules, and ensures that logging is enabled on all rules, including the cleanup rule, on any in-scope devices. Here's a quick look at the GDPR requirements we test for. The HIPAA Security Rule Assessment will be useful to anyone handling personally identifiable information covered by the Health Insurance Portability and Accountability Act. The controls contained in this assessment will look for rules that are not logging, are unused or expired, rules without a business justification, as well as overly permissive rules on your firewalls as mandated by the HIPAA requirements. There are also checks to ensure that only allowed services are permitted between the internal, external, DMZ and EFI, or Electronic Protected Health Information, compliance zones. You'll need to assign network segments to those zones, as well as document and update the protocols permitted in the FI services group. And up on your screen now are the requirements that we can verify with the HIPAA assessment. Next up, the ISO 27001 assessment is mostly checking various configurations and properties on your firewalls, but there are also some checks on specific outbound services permitted from the internal, external, and ICS external compliance zones. Don't forget, you need to assign the relevant network segments to those compliance zones for this assessment to accurately report your compliance stance. The ICS here stands for Industrial Control Systems, which are devices, systems, networks, and controls used to operate and/or automate industrial processes. Those zone-based controls will be testing whether access is permitted over the ports required for P2P file sharing applications, POP v3, IMAP v4, and SMTP service groups, which are configured by default in the FSP, along with specific checks for TFTP and Telnet services. And here are the requirements we checked for the ISO 27001 assessment. NERC-CIP is the next assessment on our list to examine, so let's have a look at that. The NERC-CIP assessment will check various device configs and properties on your firewalls. It will also verify whether the ports in the allowed ICS DMZ IP protocols group are allowed in both directions between the ICS external and ICS DMZ compliance zones, whether the ports in the allowed ICS internal IP protocols group are allowed from the ICS DMZ zone to the ICS network and ICS external zones, and whether the services in the allowed ICS egress IP protocols group can pass from the ICS network zone to the ICS DMZ zone. There are no services assigned to these groups by default, hence it'll be necessary to assign the relevant services to each group and assign network segments to define the related compliance zones. The Insecure Services group contains NetBIOS, which runs on TCP and UDP 139, and UDP 162, which is SNMP trap. The assessment will verify whether these are blocked between all zones. And here are the requirements we can check for the North American Reliability Corporation Critical Infrastructure Protection Standard. Next up, let's examine the NIST assessment. The controls contained in this assessment check various configs and properties on your firewalls, and some checks on specific outbound services permitted from the internal, external, and DMZ compliance zones. We'll verify connectivity for the services you assign to the unauthorized ingress IP protocols group, from the external to internal compliance zones, and the services defined in the unauthorized egress IP protocols group from the internal to external zones. We'll test whether ICMP, SNMP, Remote Shell, and RExec is permitted from the external to the internal compliance zones, and we'll also verify that private IP addresses are not being routed in or out of our network. And here's a look at the requirements we can test for in the NIST assessment. Before we jump into the next assessment, let's go over what it is and what it can do for you. Most regulatory compliance audits will require that you provide documentation of the benchmark your device configurations comply with, or of the hardening standards your organization enforces when configuring a particular type of asset. Benchmark assessments will inspect device properties and configuration files to ensure compliance with security and hardening requirements specified by the relevant security standards organizations. These requirements will audit your device settings for password policies, authentication, vulnerability management, antivirus capabilities, fault tolerance, malware protection standards, and many other configuration settings. The abundance of control types based on device properties, regular expressions, and rule queries offer the opportunity to duplicate one of our existing benchmark assessments to use as a baseline to create your own assessments for other standards, or customize one to audit device compliance to your own organizational policies. We'll go over how to do that after we look at the SANS security configuration benchmark for Palo Alto firewalls, which is a great example of how you can leverage the tools in the FireMon Solutions portfolio to audit compliance to industry or organizational standards, dictating optimal hardening processes to be followed when configuring your security devices. So let's take a look inside that SANS Palo Alto assessment to get a better understanding of the requirements we can actually audit. The Palo Alto benchmark makes extensive use of device property queries to verify whether the configuration is compliant with the hardening standards established by SANS. There are also some rule search controls leveraging FireMon's security intelligence query language that examine the policy and rules and confirm they also meet SANS requirements. Here we can see the controls that will check the firewall's password policies, various authentication settings, here are the controls checking vulnerability management configs, antivirus capabilities, and the settings for high availability. And finally, here are all the configuration settings we verify with the SANS Palo Alto benchmark assessment. Alright then, as promised, let's learn how to customize one of those default assessments to suit our particular needs. Looking here at our list of pre-configured assessments, you'll notice they all have a lock symbol in front of the assessment name, which tells you this assessment can't be edited. However, you can duplicate the one that's closest to what you want, then edit the duplicate, and make it your own. The one exception is the PCI DSS assessment, which we'll be looking at next, as it's been sanctioned by the PCI Standards Council and is therefore copyrighted. You can use any other one of these as a template for your own assessment. You need only find the one closest to meeting your needs and modify it as required. Since we're now so familiar with the Palo Alto benchmark assessment, let's use that one. As I hover over the three-dot menu on the right of the screen, notice the lack of Edit option on the list. Selecting Duplicate here will open up a window where you can give your assessment a unique name and an optional description. Then select Duplicate again from inside here, which will place your new copy on the menu. Back on the three-dot menu of your duplicate, notice, in fact, you now do have the option to edit, which is what we'll do. And now we can edit to our heart's content by expanding the Assessment Builder section and locating the requirements and controls we'd like to change. Notice the assessment is divided in sections and subsections that organize it in groupings that show the top-level requirement, as well as subsections nested below them. It's recommended to use these to create a logical structure for the requirements you need to meet and the controls within them that will test your devices. The sections also dictate the format of any reports we eventually run against this assessment. You might also notice that the Assessment Builder automatically opens up any sections that have a control configured. As you can see here, we have a section 2.6 that specifies the Palo Alto security profile settings. When we expand that, we see there are subsections that specify the various profiles, and if we open subsection 2.6.1 for antivirus, we find subsection 2.6.1.1, which takes us down to the level where there is a specific control applied, which we can look at by selecting the three-dot menu on the right and clicking Control Details, showing us the actual device property control that will verify whether this particular profile is enabled on our Palo Alto. We can modify the entire assessment at will. If I go back up to the section that is home to the control and select the three-dot menu again, I have the option to add more sections or subsections, disable the control if it's not applicable to my environment, which will prevent false positives, never something you want on a report that'll end up in an auditor's hands, or if you're looking to add another control or delete this one and replace it, you have that option as well. Perhaps we have a need to build a more generic benchmark and we want to test that no insecure login services are enabled. We probably want to start by changing the title at the top section of the assessment and remove the reference to the SANS requirement. Since this is a duplicate of the Palo Alto benchmark, this first control checks whether the login banner is enabled on that specific vendor platform, so let's change that first. First, we'll change the section of the title. Next, we'll add a new control to test our devices with. Click Add Control on the three-dot menu of the section, which brings up a search box to help you find the right one. Next, we'll add a different control to ensure that Telnet is disabled. Now we can see that the control will test what we expect by viewing its details. And now we can delete the old Palo Alto control. We would continue modifying our new benchmark assessment in this manner until we have all the desired controls in place, then hit Save, which will take us back to the assessment list, where we'll now open the Assignment tab and select the devices we want to assign to test against these controls. Since it's a login control, I'm going to choose all devices. Once I've assigned devices to the assessment, I'll be constantly auditing them against all of the controls within it. There you have it. You've created an assessment. And that brings us to the end of the benchmark. The Sarbanes-Oxley assessment is relatively small in comparison to the PCI assessment, so we'll look at SOX first. The SOX assessment doesn't reference any compliance zones or service groups. The controls contained in this assessment will check for things like unused or expired rules and various best practice violations on your firewalls as mandated by the Sarbanes-Oxley Act. There are also checks for overly permissive rules, ones that have any in either the source, destination, or service fields. A check to verify implied deny rule is in place, as well as controls to detect rules that permit services exploited by known vulnerabilities, assuming you have the Risk Analyzer module licensed. Now here's a quick look at the controls inside that SOX assessment. Okay, it's now time to take an in-depth look at the PCI DSS 3.2.1 assessment. The controls contained in this assessment will check for things like unused rules and various best practice violations on your firewalls, as mandated by PCI DSS requirements. There are also checks on specific services permitted between compliance zones, which you'll define by assigning the relevant network segments in the administration panel. The PCI assessment uses the following compliance zones. The PCI network is equivalent to your card data environment, or CDE. This zone houses any devices, typically database servers, that process or store credit card data which has been encrypted or modified in a way that allows for secure handling. The PCI management zone will typically contain devices with access to or from your PCI network, or CDE. These are known as connected systems in the world of PCI. The PCI wireless network compliance zone will be defined as any network ranges assigned to users connected to your wireless access points, specifically those with access to or from your CDE. The DMZ compliance zone will typically sit between two firewall devices and has some form of reverse proxy to allow for the collection of card data from insecure external networks. This zone may also contain devices that modify or encrypt the card data upon collection. The internal zone will be defined as any registered or private IP network segments used inside the network perimeter of your organization. The external compliance zone is a special case, as it will be defined by any network segments outside of your network perimeter. It is possible to use a summarized list of the network address ranges that define the Internet, modified to exclude any ranges used internally. However, in versions 9.7 and up of the FireMon solution portfolio, there is a simplified method of defining this zone as a negation of all segments assigned to other configured compliance zones. You need only move the Compute External Zone switch to the on position. There are 7 service groups that are used to test which ports are open between those compliance zones. Some of these groups are configured with default protocols. However, these services are not mandated by the PCI Standards Council, hence you can modify them to match the approved list of services and protocols you should have to meet requirement 1.1.6. The PCI Allowed Services group specifies protocols that are permitted from the external compliance zone and other networks into the PCI network zone, which is where your card data lives. The default services in this group are FTPS, HTTPS, SSH, and Secure Telnet. The PCI Database Services group specifies protocols permitted from the PCI DMZ compliance zone into the PCI network zone. The default services in this group are MSSQL, or TCP 1434, and PostgreSQL, or TCP 5432. The PCI Allowed Wireless Services group specifies protocols that are permitted from the PCI Wireless compliance zone into the PCI network zone. The default service in this group is SSH, or TCP/22. The Unauthorized Ingress IP Protocols group contains protocols not allowed from external networks into the PCI DMZ, from external networks into the PCI network, and from the PCI DMZ into internal networks. No default services are configured in this group, so it must be populated according to your approved list of services and protocols document. The Unauthorized Egress IP Protocols group contains protocols not allowed from any network to external networks. There are no default services configured for this group, which must also be populated according to the approved services list document. The Insecure Services group specifies protocols not allowed from any network into the PCI network. Its default services are NetBIOS SSN, which are TCP and UDP 139, and SNMP Trap, which is UDP 162. The PCI Non-Console Admin Access group lists ports allowed from the PCI Management Zone into the CDE, or PCI network. The default services here are HTTPS, or TCP 443, SNMP, which is TCP and UDP 161, SSH, TCP 22, and ICMP Type 8, Type 13, Type 15, and Type 17. And here are the requirements we test against for the PCI DSS 3.2.1 assessment. Well, thank you for watching. I hope that you found this overview of regulatory compliance to be useful. For additional details on the topics covered today, there are more videos that take a deeper dive into these topics, including control configuration and out-of-the-box assessments and controls on the FireMon User Center at https://usercenter.firemon.com.